Okay, geometry, we're in the last section of chapter 2. We are in section 2.8, which means that next week we'll start review and we'll do test over chapter 2. So be thinking about that in the near future. This section is talking about, it starts with sig figs. And I know that most of you probably had sig figs in one of Mr. Moose's classes. And so let's start off with the rules for sig figs. And then this does kind of dive a little bit deeper into doing some calculations with sig figs, which I know you've done before, but this is maybe a little bit different. And so let's talk about the 4 rules. So the first rule for sig figs is that anytime you have a number that is not a 0, it's considered significant, like any non-zero digits. So I'm going to underline the word non-zero. Any non-zero digits are always significant. So here I have 2.14. 2 is significant, 1 is significant, 4 is significant. That is 3 sig figs or 3 significant digits. So no question about that, okay? The second thing says if it's a 0, but it's in between 2 non-zero numbers, like this 0 is in between 5 and 7, that 0 is also going to be significant. So if it's zeros are between significant, zeros are significant if they fall between non-zero digits, then they are significant. So this would have 4 sig figs. The 0 here would be considered significant, okay? Now, if it is a decimal number that is greater than 1, this is the third one. If it's a decimal number greater than 1, like 7 point something, right? Or 1 point something, or 13 point something, whatever. When this digit is not 0, like this one's 0, we'll talk about what he's going to do, okay? If this decimal is a number bigger than 1, any ending 0 is going to be significant, okay? So that's going to, like let's say it was 7.600. Any ending digit that is 0, as long as this number is bigger than 1, any ending digit that is 0 is going to be significant. Now, does that make this one significant? Yes, because 6 is significant, 0 is significant, so this 0 is also going to be significant, okay? So in that case, this would have 4 sig figs, this would have 3 sig figs, okay? Now, number 4 says if it's a decimal less than 1, so like 0 point something, right? If it's just spacing the decimal, those digits are not going to be significant, okay? So this would only have a 2 and a 9 that would be significant, okay? It could be 0.00000, whatever. Let's say it was 150, right? Okay? Now, these zeros here are just spacing the decimal. And let's see, in decimal number greater than or equal to 1. Yeah, I don't think this 0 is significant, actually, because it's not a decimal number greater than 1. So here would only have 2 significant figs. Again, this 0 is not going to be significant because it's not a decimal number greater than 1. Oh, no. In decimal numbers less than 1, the first non-zero digit and every digit to the right. Okay. That's why it was looking funny. I was like, I can't find the rule that says that, but I know this 0 is significant. So this would have 3 of them. So since 1 and 5 are significant, everything to the right of that 1 is going to be significant. So the ending 0 is significant, but the ones that just space the decimal are not. All right, there we go. All right, example 1, determine the number of sig figs in each measurement. Here we go. Oh, this is exactly like the one that I just gave you. So these 2 are not going to be significant because this is a decimal number less than 1, but the 3 and the 2 are, and that means everything to the right of 3 is going to be, so this is going to have 3 sig figs. 3 sig figs, I don't know. 3, this is a decimal number less than 1. The first non-zero digit is 3, and there are 2 digits to the right of 3, 2 and 0, so this measurement has 3 sig figs, okay? All right, this one, centimeters. All right, these 3 zeros are not, it says, okay, because this is a whole number, zeros are only significant if they fall between non-zero digits. So this 0 is going to be significant, but these zeros are just basically spacing the decimal, kind of like these zeros only space the decimal. So these 3 zeros are not significant, but these 3 numbers are. So there is 1 0 that falls between 1 and 7. So this measurement has 3 sig figs, including that first 0. Okay, all right, sig figs, done. All right, now it's going to get a little bit confusing to you, so make sure you're listening to this. Find the possible range for the length of the segment using the correct number of sig figs. Okay, here we go. So this measurement is at 1.5 inches. Like, we can see that that's 1.5, and it says this measurement is given to the nearest 1/4 of an inch. All right, now how do I know that? How do I know it's to the nearest 1/4 of an inch? Well, my ruler right here is only marked every 1/4 inch going through here. Okay, most of the time you'll see rulers that are marked every 1/8 of an inch or 1/16 of an inch, right? Like, there's 16 markings here, right? Okay, and that's a little bit different, but this one's marked every 1/4 of an inch, so that means I'm rounding to the nearest 1/4 of an inch here. Okay, so when we talk about the possible range for the length of the segment, these dots are getting rounded to the closest marking here. Okay, so what's happening here is this marking, or this dot, is going to get measured at this amount as long as it is in between here and in between here. Okay, like, let's say this dot was actually like right here, it's going to go and round to this guy. You're going to say the closest measurement is 1.25 inches. Okay, so the way that this works is, because it's kind of like, if it's more than 5, if it's, what is it, if it's 5 or more, shove it higher. If it's 4, let it sit. I don't remember what it was. Anyway, so one of you guys is going to tell me on Monday. Anyway, so anywhere between these two markings, it's going to round to 1.5. Okay, now what is this marking right here? This is 1.25. This is like 1.25. Okay, but what's this marking right in the middle here? If this is 1.5, what's exactly between 1.25 and 1.5? 1.375. That's 1 3/8, and this is 1 5/8, or 1.625. Okay, so if it is a number, or if that dot would have fallen anywhere like up to the 1.375 mark, right? Like anywhere below that, but up to the 1.375 mark, or below the 1.625 mark, I'm going to label it as 1.5, right? So let's see. The exact measurement is between 1 3/8, which is 1.375, and 1 5/8, or 1.625. Okay, hopefully that made sense. We'll do another one here, and you can kind of see like the trend. All right, so again, anywhere between those two, it's going to round to this marking right here. If this dot was actually here, it would round to this one. If the dot was outside of here, it's going to round to that one, right? But if it's in between those two, it's going to mark there. Okay, due to the precision of the ruler, the length of the segment has has actually 4 sig figs, because each one of those numbers has 4 significant digits. Okay, so that's how that works. All right, because even though 1.5, which is what it was originally, the way that I'm rounding, since I'm now rounding to the nearest 1/4 of an inch, it could be off by any of that amount. It's actually 1/8 of an inch on either side of that 1/4 inch. 4 sig figs is what that is measured to. Okay, so find the possible range for the length of the segment. So here we have centimeters, and this looks like it's right at about 2.2. So I'm going to make this a little bit bigger. I'm going to do this over here, and this might help. Okay, so 2.2 is what I have measured him at right here. There's where my dot is. The next like marking to the left of him would have been 2.1, and the next marking to the right of him would have been 2.3, right? Like, that's what this mark is and this mark is. Okay, so if it's any bigger than this spot, which is in the middle, it's going to round to 2.2. If it's on this side, it's going to round to 2.1, right? Like, if it's the dots over here, it's going to round to 2.1. Okay, and same thing here. If it's anything less than that marking, it's going to round down, right? Well, what are these two markings? Like, what's halfway between 2.1 and 2.2? It's 2.15 and 2.25. Okay, so I can say that if my dot lives anywhere between 2.15 and 2.25, it is going to round to 2.2. Now, that's easier to see when it's blown up, but like here, it's going to be a really small window, right? Okay. So the answer here is part C, or is letter C, 2.15 to 2.25 is what that actual range of measurement is. So that's a little bit different than probably what you've talked about in Mr. Booth's class. Okay, now we're going to do some calculations with that. So calculating with sig figs, I'm going to do add, subtract. So plus minus rules over here and multiply, divide rules over here. Okay, when you're adding and subtracting, you take the the least number of decimal places, right? When using adding and subtracting and calculation, cannot have more digits to the right of the decimal. So you take the least number of decimal places. Maybe I should move this down a little bit. For example, if I have like 2.1 plus 3.45, let's say, right? If I add those two together, that would be 5.55. But since this guy only has one decimal place, even though this one has two, I can take only one decimal place. So instead of this being 5.55, that would actually be 5.6. Okay, I have to round to one because that 5 is going to round him up, right? I can only carry one decimal place, so that's how that works, all right? When you're multiplying and dividing, you just go off of the number of sig figs. So if I take 2.1 times 3.45, I got to get my calculator out to do that. Okay. It is 7.245. Okay, now that's the full thing, but the rule for multiply divide is the least number of sig figs. So this number had 2 sig figs, this number has 3 sig figs, so I can only carry 2 sig figs total, including decimals and everything. So 2 sig figs would be these two, and the 4 is going to round that 2 and stay at a 2. So 7.2 is my final answer. Okay, now notice that we don't round or we don't do anything with sig figs until after the calculation has been made, right? So that's how that works. All right. Example 3, find each measurement rounded to the correct number of sig figs. All right, if we have this for a volume and we remove this amount, removing means we're going to subtract them. So I'm going to go down here to this line where it has the subtraction. Normally I don't go off of their work, but I'm going to this time. 516, because they have it good. All right, when we take and subtract those, I've got this going on here, okay? But adding and subtracting, the rule is we want the least number of decimals, right? So this one has 2 decimal places, this one has 3 decimal places. So I'm only allowed to carry 2 decimal places, 1, 2. That 4 is going to make that 2 stay as a 2, so it's going to be 560.72. It's going to stay like that in milliliters, all right? And the reason why we have to have these rules is because we can never assume more accuracy or more precision, I should say. Here I'm throwing around accuracy and precision. We can never assume more precision than what we're allowed to. So this one is not as this measurement is not as precise as this measurement because it's not rounded to the correct decimal place, right? Or it's not rounded to as far of a decimal place. So our answer is not allowed to be more precise than what our initial measurements are, if that makes any sense, okay? All right, now let's do area. This is multiplying these two together, so 4.25 and 2.5. I'm going to go here. 4.25 times 2.5 is 10.625. Okay, now the rule for multiply divide is that we can only carry that many decimal places, right? Using the figures, the area is this many square inches. This guy has 2 sig figs total, not decimals, 2 sig figs total. This has 3 sig figs total. So we are only allowed to take 2 sig figs, which means we're rounding to this number, right? This is my first sig figs. This is my second one. The 6 is going to round that up to 11. So I have to like drop all of my decimals, and this is going to be 11 square inches. That's all the more precise I'm able to get with my final measurement based on the 2 things that it gave me, okay? All right, let's go down to this one. Example 4. The world's second largest flower garden is this thing in the Netherlands, which covers 79 acres and contains 7 million flower bulbs. Okay, around 30 gardeners work together each year to design the flower formations. We don't need to know that. That is useless information. We don't care. How many bulbs do they use in each square yard? Okay, we have 79 acres and it's 7 million flower bulbs. So what they're doing here, we could have skipped over this entirely because we kind of know the rules, but there's one thing that I want to bring to your attention on this problem, and it is this right here: 7 million bulbs and 79 acres. Okay, the deal here is that 7 million bulbs, that is not a measurement, that is a quantity. Okay, and quantities are different than measurements. Like quantity is like the number of people. I didn't estimate. There's no estimation that's going on when I'm giving you a quantity, right? No estimation, right? When I'm giving you a quantity. Versus acres are estimated, right? Like acres of plots of land. Those are measurements, right? And so, let's see. So right here, even though 7 million only has one sig fig because these zeros are insignificant. It only has one sig fig. I'm not going off of the 7 million with one sig fig because that's a quantity and that's not estimated, right? I'm only going off of the 79 number, which has 2 sig figs, right? So I am allowed to carry 2 sig figs in my final answer because I have that going on. All right, now 7 million bulbs, 79 acres. I'm dividing that, but then they give me this information. 1 acre is 4840 yards squared because they want the answer in square yards. That's not a number that I know off of the top of my head, but they're giving it to me. And we have like our little railroad track things going on here, and we end up doing that calculation, and I don't know what it is. No, I can't even cheat. 7 million divided by final answer 18.3074. But we are only allowed to carry 2 sig figs because of my 79 acres, so it's going to round to 18 bulbs per square yard. Okay, now it tells you down here, it just tells you that again, because the number of bulbs is a quantity and not a measurement, the number of sig figs is determined by the measurement, which is 79, and 79 has 2 sig figs, so my final answer can only have 2 sig figs. Thus they use 18 bulbs in each square yard. Okay, all right, so that's a funky weird thing. All right, a couple more. Here we go. The radius of a circle has the measurement shown. What is the possible range for the area of the circle? All right, so let's talk about, we're doing area of a circle, and area of a circle is pi times the radius squared, and they're saying that this is the measurement for the radius of the circle. All right, so let's see what this measurement is. It looks like it is that going off of 10? Yeah. Is there 10 markings there? We're in centimeters. Yeah, so that's 7.6 is what it is, right? Okay, now I'm going to do my little fancy thing over here, and I'm going to blow this up. I'm going to like zoom way in, right? 7.6 lives here. I'm going to go 7.5 lives here, and 7.7 lives here, right? Like those are the 2 markings on either side of the 7.6, okay? Now, if it was anywhere between this mark and this mark, it's going to round to 7.6, right? Okay, so the lowest possible value that my like radius could be is 7.55, because if it's any below 7.55, like over here, we're going to call it 7.5 instead, right? But if it's any above 7.55, it's going to round to 7.6. Same thing here, 7.65 is halfway between, so if it's any lower than 7.65, it's going to round down to 7.6, but if it's slightly above, it's going to go to 7.7, okay? So this is kind of like blown up from this little bit right here, okay? So the absolutely lowest value that my radius could be is 7.55. So what I'm going to do here is I'm going to say the radius has to be greater than 7.55, but it has to be less than 7.65. And then technically it's this way, right? It's greater than or equal to, or less than but not equal to, whatever. I'm not going to get too picky about the equal to parts of it, right? But that means the lowest area is going to involve the 7.55 number. This is the absolute lowest my area could be, and the absolute highest my area could be is pi times 7.65 squared. Okay, so we're going off of what like the measurements are on either side, like what that value could have been at the bare minimum, right? Going out to one more decimal place. Okay, so I'm gonna go 7.55 squared, and I get 179.07. I'm gonna give a bunch of sig figs and then we'll pull it down. Okay. And the area has to live between these two. Okay, 7.65 squared times pi, and I get 183.853839. Okay, now this, each one of these had at the minimum, actually pi has an infinite number of sig figs, right? Like pi goes on forever, but the minimum number of sig figs that I have, and I'm multiplying again, so I don't go off of decimal places. I don't say that this is 2. This has 3 sig figs and 3 sig figs. So I'm only allowed to use 3 sig figs in my answer. And so this guy is going to be 179. And this guy is going to be 184 because that 8's going to round him up. So at the bare minimum, my area is 179, and at the maximum, my area is 184. Now that's not too bad of a window, right, between those two, but it's still kind of a decent sized gap. 5 centimeters, that's like a 5 square centimeters. That's a lot to be off by. So what do I do instead? Like, how do I make this window a little bit smaller, right? Like, how do I make that window of, basically this is like your margin of error for your area, right? How can I guarantee that that margin of error is as small as possible? Well, what I'm going to do is go out and use a smaller increment of measurement here. I'll go to the nearest millimeter instead of the nearest centimeter, and that's going to give me a smaller window of error for my area. Whatever. Anywho, there you go. And that is it. Okay, so here's homework assignment. I think 20 and 26 maybe are going to be those harder problems that you have, and try to do those. I don't know if you guys go off of this, but if I ever get stuck like looking at a problem, I'm like, oh, I know that 1 through 6 goes back to example 1, so I'm going to look at example 1. I know that 8 through 16 evens, 8 through 12 goes back to example 2, and 14 and 16 go back to example 3. So that type of stuff. When they're talking area of a triangle, by the way, this is one of the formulas that you have to know for this test, but area of a triangle is base times height divided by 2. So keep that in mind. That's what you're doing for this over here, okay? And then just make sure that you're always concluding it to the correct number of sig figs, okay? All right, there you go. Do that for homework. Happy Friday. Have a good weekend.